In this video, I'm going to be going over the assembly instructions for this 2 LED flasher board. This is both for ELTN 130 and 115, and it's for our soldering unit this week. So in the previous video, you saw the setup for the Vastar soldering iron. You want to make sure you turn it on and that it's up to temperature. It usually takes a few minutes. And I found that setting the knob, it's a little hard to see the front of it, but if you set it right about straight up and down 4.5, it works pretty well. So these kind of weird alligator clip things are called helping hands, and they're basically used to help design. They're designed to hold the board in place, and that's really convenient when you're trying to solder. You don't want to try to be pushing things around or just lay it down on a smooth surface. I also recommend getting some kind of mat, like maybe a placemat or some kind of material, so you don't end up getting solder balls or anything on a good surface. When soldering a circuit board like this, we usually start with the components that have the lowest profile, or kind of the flattest parts on the circuit board. It makes it a little bit easier to assemble. Also, we typically will do only maybe one or two at a time, and the reason for that is that we don't want to have a bunch of wires sticking up on the other side that we're trying to solder. So for resistors 1, 2, and 3, these are all 1K resistors, which are brown, black, red. And the fourth resistor is a 10K, which is brown, black, orange. So make sure you keep track of those color codes as we're going through them. You don't want to solder one in the wrong place. For these resistors, what I'm going to do is bend it at a really tight angle right up against the body. So it looks like that. And then I'm going to slide it in the holes on the top. Push it all the way in. And if you take a look at this from a side angle here, you'll notice that the resistor is really flat to the board. It's not sticking up. You do not want to be soldering where the part sticks up like that. The term they use in industry is called skyscrapers. No skyscrapers. So we're going to push the resistor down, and I'm going to bend these leads out, maybe at a 30-degree angle or so, to keep it from moving, and that should keep it from falling as we actually solder it. So I'm going to go ahead and solder that first one, and then I'll solder the rest of the resistors. So I'm going to clean off the tip of my iron pretty much between every solder connection. And what I'm going to do before I actually make a solder connection, I'm going to put a little bit of solder on the tip, just like that. What that does is it increases the surface area and makes the solder connection a little bit easier to make. I'm going to heat the connection and apply the solder like that and remove it. That's about as long as it takes, maybe a couple seconds at the most. Now you'll notice a couple of things. I'm not poking the tip of the iron down. I want to have as much surface area as possible on the connection point. And to do that, I'm almost kind of coming in at a side angle here. Remember, for soldering, we want to heat the connection and let that melt the solder. Do not put solder on the tip of the iron and then try to wipe it on the connection. Solder's not a glue, it won't stick to it. So if we do this properly, again, I'm going to put a little bit of solder to help the heat transfer like that. I'm going to put the tip of the iron there, heat the connection, oops, and then melt the solder on the other side. A little tricky to do this with a camera. So a good connection, if you take a look at these solder connections, they should kind of almost be like a fillet, kind of like a little, or some people call them like a little volcano. This one on the right has a little more solder on it, but it's still okay. The main thing we want to do is make sure that the hole is covered and that we don't have solder dripping onto other points. And when I clip the wire, I'm going to use the diagonal cutters here. I'm not going to try to go way flat to the board, but a little bit higher. Hold on to the wire while I trim it to keep the wire from flying away. And we'll clip the other connection like that. So when it's done, it should look something like that. The kind of the goo and the little bits that get on the side are from the flux typically. When you're done, you can use a brush or something to wipe those off. That doesn't really cause a problem at all for these circuit boards that we're building. So I'm going to go ahead and solder the other resistors, and we'll get on to the next components. So one question students will ask is, does it matter which way the resistor is soldered in, from left to right? And the answer is no. Electrically, resistors do not have a positive or negative lead. They're not polarized. But it's better typically to kind of lay it out so that the gold band is on the right, so that it's a little bit easier to read the value. So these are, again, the three 1K resistors are on the left and the 10K resistor is on the right. So next we're going to solder on the capacitor, one of the capacitors. So this is a 10 microfarad capacitor, and you'll notice that one lead is longer than the other. That's the positive lead. Almost all devices have that kind of orientation. And also there's this kind of rectangle, that's the negative terminal, that's for a minus sign, and that's on the shorter lead. So the way I'm going to plug this in, it's a little hard to see, but there's a tiny little plus on the bottom there of the board. So we want to make sure that the longer lead of the capacitor is plugged into that positive lead, and the negative is on the other side. If that capacitor is soldered in backwards, the circuit simply won't work, it won't flash. So make sure you check that, so that that white band should be on the left. Next I'm going to solder C1, which is this white capacitor. I think it has a value printed on the top here. 10N stands for nanofarads, which is the same as a 0.01 capacitor. So this one is on a piece of tape. We need to clip it first and then insert it. Doesn't matter which way in this case, but again, I think it's better to have the value showing the proper way there, so it's a little easier to read. So I'm going to flip it over, bend the leads out, a small angle. Sometimes if it's really loose, you can put some tape on there, up to you. And then I'm going to go ahead and make the solder connections on there. Zoom in a little bit. And again, you want to clean the tip between each solder connection. Again, tin it with a little bit of solder. Hold the iron, heat the connection, put the solder iron on and release it. Soldering just takes practice if you haven't done it before much. And it just takes a little bit of time and practice to get really proficient at it. But circuit boards are pretty easy to solder by comparison. So I'm going to heat that connection, solder it, and here we go. And you don't want to have your solder be so much that it's like ends up looking like a ball. It should be, again, kind of a relatively short, kind of a conical shape. I clipped this one a little low there probably, so it's a little hard to see. Next we're soldering the LEDs. We have a green LED and a red LED. You'll notice on this LED, if I can get it to focus, that there's a flat on one side. That's the negative side, and the longer lead is the positive. So the flat here is going to line up with the flat side on what's called the silk screen, the marking there. So this is the green LED. So what's important here is that the two flat edges are going to face each other. So check the LED. The longer lead is going to be to the right in this case, shorter lead that way. For the red LED, again, I'm going to locate where the flat is on there. If you look kind of straight on it, I don't know if you can see that too well. It's a little hard to see, but you can see the flat on the right-hand side. And it's a shorter lead. So we want to make sure that those two flats are lined up. If that isn't soldered properly, it's not going to flash that LED. So we want to make sure those are both pushed in there all the way. And I'll go ahead and solder those. Okay, the last main component that we're going to be soldering on here is this little integrated circuit. It's a 555 timer. And the way we want to orient this is, if you notice, there's this little dot kind of in this corner here. And also if you see the way that the printing aligns from left to right, SC555P, yours might have a slightly different number. We want to line it up so that is lined up the same way that we see the text here. That little notch indicates that left side of the device. Now, if you'll notice, when we take this part out of the foam, that the leads are kind of at an angle there. What I'm going to do is bend them straight. It's probably a little bit better to do this on a table or a flat surface. But if I bend them straight, like that, then I'll be able to plug it into the circuit board fairly easily. Okay, so that's plugged in. And what I'm going to do is flip it over, hold the device, turn it over, and bend these leads out just a little bit. You can use a screwdriver to kind of pop those a little bit. You don't want to have them completely flat, but that'll hold it in place so that when we're trying to solder it, it's correct. Whoops, have that flipped over there. Okay, and again, you just want to make sure the text is oriented properly before you solder it. It'll be difficult to unsolder this otherwise. Okay, I'll go ahead and solder those 8 wires there. These have nice big pads, so it's fairly easy to solder. When you're all done, what you want to do then is take a look at your board and see how everything looks. So if we look at it carefully, we can see that all the solder connections look good. They're shiny. Nothing bridging. We don't have solder between 2 points. And also, the other thing to look for is none of these look like big balls of solder. So even though the wires stick up a little bit, that's fine. Okay, last thing we got to do is solder on the battery clip. We'll do that real quick, and then we'll see if it works. Okay, so this is the battery clip. Positive is the red lead. I'm going to place that in there. Negative is black. Slide that in. What I'm going to recommend is that after you solder these, that you use some kind of glue, epoxy or super glue or something to hold those in place, because if not, if these wires keep getting bent, they'll break off pretty easily. Okay, so I soldered that. I'm going to clip these leads here, and we're all done. Okay, so let me grab a battery and we'll test it here. Okay, so I'm going to connect the battery here. Make sure you don't connect it backwards because you could damage it. So we'll plug the small one into the big one and hook it up, and there we go. Now, if before you assemble this, you want it to flash a little bit slower, you could probably use a slightly larger value for the 10K, or you could use a larger capacitor. I think this is a 10 microfarad. You could probably use like a 22 or 47 microfarad. I think you've got those in your kits. And we can do some substitutions on the other parts. But that's it. If you have any questions as you go through this, let me know. But make sure again that you watch the Vastar soldering iron introduction and the soldering videos.